Hello community! Today we talk about can AI predict the future, and of course we only talk about AI forecasting because this is a science channel, and we're looking here at the reasoning and tools for forecasting framework. And there's a beautiful new work done by UC Berkeley, and it uses here a combination of the reasoning and of tool usage here in language model. So simplest case we can imagine is we have access to some online knowledge. Can be over API calls or over RAG, whatever you have. This is the simplest case we can imagine. And then we need a numerical computer simulation of a particular topic. Easiest case, maybe about the weather, maybe about some other material science, maybe about something in theoretical physics, maybe something about financial stock prices or whatever. So whatever we have on computer models and computer simulation, we use now this simplest combination of just two elements. Now, in the old OpenAI, we had a Python interpreter. Now in Anthropic, we have Claude artifacts. Or if you fork here VS Code, we have here our Cursor, our AI code editor. That is simply amazing. Why do we need online knowledge? Now, think about it. There's a temporal pattern in our data. Let's say financial data. And we have a particular pattern. And we have first here this. Then we see that we have this, then this, and then this. And finally, we have here this. Whatever this is, just use your imagination. It doesn't matter at all. And now imagine we are looking here in real time in data, maybe in seconds, maybe in days. I don't know. And we see, we have now the following real-time pattern. We have this, then we have this, then we have this, and then we have this. And now you can say, okay, maybe now is time to act. I can now go and predict the probability that this event is now going to happen. You can say, okay, I do it here from a time series from the past, or you say, I'm working in a dynamic environment, so I need a numerical computer simulation in whatever area you are. So you see, it is simple, and here we have beautiful publication, UC Berkeley, end of August 2024, reasoning and tools for human-level forecasting, of course, done by an AI system. And they call this here the reasoning and tools for forecasting, the RTF framework. And it's based here on the very old React reasoning and act agent. Now, I have here already some RAG Python notebooks where I show you how you can do this, never mind. And more than a year ago, I was talking here about React and chain of thought and whatever, and we looked at AWS Bedrock agents years ago, but never mind, this is old stuff. We know that we have more or less two different types of forecasting. We have a statistical forecasting, we have time series modeling in Excel, so abundant data under stable condition. And then what we have is a chaotic forecasting, a judgmental forecasting, relies on human expertise, and you might say, my goodness. We integrate historical data, some specific domain knowledge, and some human intuition to make prediction. And yes, this is pure chaos. So let's try to do it a little bit better. And UC Berkeley is here, beautiful with their study about forecasting task by integrating tool use for our LLMs. Core idea here of this research here by Berkeley is to extend the capabilities of a model to perform better in forecasting by integrating tools that allow them to retrieve at first, first block, updated online information, and then with this brand new information from the last second, we run some simulation that maybe simulate the next minute in a financial system. For example, or use it whatever you want. So therefore you have it, the RTF, the reasoning and tools for forecasting, build upon the old React framework. Now it's a combination of reasoning and acting, and now an LLM is equipped with tools like a Python interpreter for running those simulations and an API for retrieving real-time data from your company database or whatever you have online. So for my green grasshoppers, what is it? It is continuously we have to adapt to a dynamic data stream and deduct decision. What could happen? What is the probability of the different system evaluations in the future scenarios? Now, we know that it is working because if we look here at this publication from June 2024, remember this is already version 4 of the paper, learning to use tools via cooperative and interactive agent with LLMs. A real nice study. If you're not familiar with this, always check that you have the latest version of the paper, please. And we also know Here, this paper from July 2024, Wisdom of the Silicon Crowd, where we have an LLM ensemble prediction capabilities, and they reveal here the human crowd accuracy, and they did a test with a human crowd of 925 human forecaster for a 3-month period. Highly an interesting study. If you have not read this, please put it right next to your bed. Read it in the evening. Okay. Now, you are familiar with React. I have nothing to tell you. You know that it's based here on the chain of thought, prompting and acting. But you know that in this study, they showed that only a chain of thought prompting, and even if you provide some in-context example, is not really help, because the system can iteratively hallucinate and produce incorrect responses on more complex tasks. And please note that we are here talking about more complex tasks. We are not talking about a single binary logic decision. No. Complex task, chain of thought is not working, and this was one of the reasons why, long time ago, React was invented. Here's the study by React Synergizing Reasoning and Acting in Language Model by the Department of Computer Science, Princeton University, and Google Research, the Brain Team. Great. So if we want to take this now and go the next step in the evolution, become better, what we do? Now, we introduce hierarchical planning. And here, I give you here the most important sentence of the study by UC Berkeley. They say we define here pi by an aggregate of a collection of hierarchical React agents with tools for real-time data retrieval, you remember the first block, and simulation, the second block, or numerical calculations, expanding here the observation on everything for a Python interpreter. You have maybe a Google search API, or whatever combination you have on tool use for our LLM. But the most important part is now the idea here is hierarchical planning. So, key technique here involves hierarchical planning, where high-level agents manage here the abstract logic and forecasting task, while our little minion LLMs, our little minion agents with a low-level agents, handle the data retrieval and specific numerical computation in our computer models, where we allow our AI agents to have access to our supercomputer simulations. This structure is essential for reducing the cognitive load on the model, allowing it to focus on high-level reasoning without being bogged down by the little gritty things of data processing and so on. Does it work? Well, that's interesting, but let's have a look at it. What you would say? I think Darwin would say, here we witness the slow evolution of a single React agent crawling out of the ocean and discovering a new habitat and slowly evolving to a multi-ensemble React agent environment where we have hierarchical planning. So we have not a revolutionary new innovation, but this is the good old step-by-step innovation. Key assumption, I don't have to tell you, updated data and performance simulation, specialized agents, beautiful. We could talk about the method with multi-agent system and a high-level React agent oversees the whole thing. I could tell you about the flow here, data collection, action, execution, hierarchical planning, and the ensembling. But you know all of this and you understand that the strengths are scalability, adaptability, and efficiency. Talking about the results, they show that a well-calibrated small ensemble of language model can achieve better results than larger but less optimized ensembles, challenging the notion that more models always lead to better prediction. And they show sometimes they also can surpass here the human prediction in some cases, but we are on the right track. If you want here the numerical results, as you can see, for a specific condition, and they do not give us their code base. So you see here for GPT-4, Llama 3, and GPT-4 Omni, we have an accuracy of up to 65%. And then if we use here the RTF, we have here an accuracy of up to 73%. So you see, GPT-4 Omni, 65%. The human crowd, with 970 whatever people, 73%. And here the RTF, the mean is exactly 73.9%. So it is a little bit better than the human crowd. Okay, whatever. Who cares about this 0.1? But you see, we are moving in the right direction. So this is a little bit better than simply here a GPT-4 Omni that does everything. Now, okay, study is nice, but the main question is, how do we overtake Darwin? Give you a simple example. Cursor. And here in Cursor, I told you that in my last video, we just have here to put whatever you want, whatever decision the human does here. This is an intelligent input. This is typed in by a human. And the human in plain English says, hey, I want now that you change this and do this, and you couple this with something else together. And then Cursor simply has here the knowledge, here the AI, Sonnet 3.5 in our case, has the knowledge and simply writes the code after having been trained of I don't know how many millions of GitHub repos that simply this is here a possible way to write the code. But the human decided this on, let's call it a logical flow of commands to achieve here the goal. Why we do this, why we build here an app. So whenever you see here a logical flow of commands, you understand this is about decision. A human decided what is the next step. But our latest AI agents can also do causal reasoning in whatever parameter, never mind, but they can do some causal reasoning. And you see exactly how in the timeline, in the temporary evolution, how we can overtake Darwin here. Because in, some 3-4 months, I'm sure that the next iteration of Cursor will not need here a human typing in here some command in plain English, but maybe we have another AI agent, a high-level, logical, trained agent that is now substituting here the human and making all the decision necessary that this system, you're just saying, hey, build this app, and the app is done within minutes. What about our little Minion-LLMs? What about our little Darwins? What we want to do there? I think we still have a beautiful future if we do not go with the huge LLMs like GPT-4 or GPT-5, whatever will come, where we will have a domain knowledge complexity on hundreds of topics. And then what we need here is topic number 17. And this huge LLM has a domain knowledge complexity on this topic of 4 out of 10. Because it would be so much easier if we have a specific task with a specific domain impact that we just have a small language model which domain complexity is only on one topic, but on this topic it is 9 out of 10, and you understand exactly what I mean. Fine-tune your specific language model to the domain knowledge maximum. Great. Now, there is a problem that I'm currently working with, and this is what about you have cross-disciplinary or interdisciplinary topics that are really, really complex, that are not simple solutions that you find in a GitHub or in 10,000 GitHub repos. What if you have some crazy amount of interlinks and dependencies of all your parameters if you do a global modeling of the climate of our planet, or if you want to evaluate here the time series of potential financial impacts that we have as a society to carry in the future. So let's do an experiment. I asked ChatGPT-4 Omni, hey, analyze here the cross effects of climate change and forecast the potential financial cost if we have here an analytical approach. And I said, identify here the top 50 causes and dangers of climate change. Well, and you see, GPT-4 started with health-related issues, air pollution, water contamination, heat waves, vector-borne diseases, malaria, dengue fever, food and water scarcity, mental health issues, respiratory diseases, cardiovascular diseases, then environmental issues, rising sea level, flooding, droughts, wildfires, loss of biodiversity, ocean acidification, deforestation, melting ice caps, soil degradation, desertification, economic issues, insurance costs, agricultural losses, property damage, energy costs, job losses, supply chain disruption, tourism decline, global economic instability, infrastructure, transportation disruption, water infrastructure damage, energy infrastructure damage, building damage, telecommunication disruption, urban heat islands, social issues, displacement and migration, food insecurity, water wars, public health crisis, social inequality, loss of cultural heritage, political instability, increased criminal crime rates, stress on public services like the emergency response systems. And then identify all the costs with this. And this is not a simple task. This is a complex task. So the healthcare costs, the infrastructure costs, the insurance costs, the economic losses, the social costs. And then step 3, estimate now the financial impact here. Estimate the cost of treating respiratory diseases and the loss of productivity due to illness. Calculate the cost of rebuilding damaged infrastructure and economic impacts on disruptions. Wildfire, insurance costs. What does it mean for a single family? Aggregate everything, and they said, hey, it's a little bit too complex. What do you think? We just do the top 10. And I say, hey, beautiful. So continue with the top 10 causes and potential financial costs due to climate change. And then comes back and says, okay, and this was rather amazing. Air pollution and respiratory health, asthma, chronic bronchitis, etc. Increased emission from industrial activity, transportation, wildfires, and lung cancer, potential financial cost. And they give me here really, the United States here, the annual economic burden of asthma alone in the United States is estimated to be $82 billion. This includes medical costs, lost workdays, premature death, chronic bronchitis. Add billions more to the healthcare cost, rising sea level. What problems do we have? The direct cost, property damage, insurance cost, and. $1 trillion in damages annually by 2050. Flooding. Yes. Every dollar spent on flood mitigation saves $6 in future disaster cost. Billions of dollars. Wildfires, water contamination, public health, potential financial cost, expected financial impact. Over the World Health Organization estimates with inadequate water, sanitation, and hygiene causes over $260 billion in economic losses globally each year. Heat waves. Estimated 70,000 deaths, droughts and agriculture losses, loss of biodiversity and ecosystem services. United Nations estimate the loss of biodiversity could reduce the global GDP by 2.5% by 2030, equivalent to $4.5 trillion annually. Marine life decline, insurance costs due to increased natural disaster. And look, here they have a real nice summary of the financial impact. And this is just a very rough estimate. So you see, this GPT-4 is maybe one of the best large language model we have today on our planet. But even here, this general educated LLM gives us already here an idea what we have to deal with, the complexity, the cross-disciplinarity, and the interdisciplinarity that is interwoven. And now imagine we would train an LLM specific on each discipline. We would provide more data, more scientific models, more computer simulation, more input from the scientific literature, and only train it on these topics. But let's look at the summary of the financial impacts. This gives us here health-related cost about 100 to 200 billion US dollar annually. Infrastructure and property damage, 500 billion to $1 trillion annually. Agricultural and food security cost, 100 to 200 billion dollar annually. Environmental biodiversity losses, just 300 to 500 billion dollar annually. Insurance costs, 300 billion annually. So you see, those are the problems we have to face in the future. And I'm trying here that AI, with its potential power to analyze, to combine knowledge, to calculate maybe new numerical computer simulations on all of these interwoven dependencies, maybe AI will be here really one of the instruments, one of the tools we can use as human to understand what are the costs of the future if we do not take actions and we just live as there would be no tomorrow. So you see, interesting what just today a simple ChatGPT-4 omni-model gives us here, if you ask here, for the interwoven effects of a changing climate on our planet and what does it mean on a financial impact for society.